Section 4.5, we're going to look for more congruence shortcuts. Today we're going to continue our investigation to see if there are any shortcuts to show that two triangles are congruent or have corresponding sides that are exactly the same and have corresponding angles that are exactly the same. So if we review from yesterday, we should discuss which ones worked and which ones didn't. So the two that we figured out that work to show that two triangles are congruent were side, 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 and side, angle, side, where the angle was the included angle, or the angle between the two sides. So it might look like this, side, angle, side. So again, these are two pieces of information that are enough to show that the triangles are exactly the same triangle without measuring all three sides and all three angles in each triangle. Okay, so these are shortcuts. So today we're going to test, is angle, side, angle a congruence shortcut? So in other words, if two angles and the included side, so the side is between the two angles, if these two are congruent, then are both triangles exactly the same? So in class we're going to be drawing a triangle with a side of 8 centimeters between angles that are 40 and 60. So first step, you would draw your 8 centimeter side. So take your ruler, measure out 8 centimeters. It's between your two angles, so you're going to put your protractor on one end point, measure 40 degrees, draw that line. Put your protractor on the other end, measure 60 degrees. All right, so it would look something like that. So if I draw it, it may look, so let's say this was the 40 degree. Let's say this was the 60 degree. So there's your triangle. All right, so once you draw that, this is angle, side, angle, where the side is in between the angles, or the included side. So the question says, compare your triangle with the triangles made by others in your team. Is it possible to construct different triangles from the same three parts, or will all the triangles be congruent? And even if you drew the triangle differently, if you drew it differently, so for example, if you did the 8, if you do the 60 here, and the 40 here, will that triangle look the same? And they actually will be the same. So the angle, side, angle congruence conjecture, if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So they're exactly the same. All the corresponding sides are the same and all the corresponding angles are the same. Okay, let's look at another one. Side, angle, angle. So this is when you have a side, not between the two angles. So if these two triangles match like this, then are the triangles congruent? So let's look at the following triangles. So in the first one, let's say this was 6 centimeters and this was 30. And this is 6 centimeters and this was 60. What is the measure of angle A? Well, using what we know about triangles, we can take 180 minus 90 minus 30, and that will give us, this is 60 degrees. For the other one, so this would be 60 degrees, would triangle ABC be congruent to triangle DEF? Why or why not? And this would be true, yes, because this would be angle, side, angle, which we just figured out worked. What's the measure of angle F? Well, angle F would be 180 minus 90 minus 60, so that would be 30 degrees. And this says, explain how this shows that side, angle, angle is a congruence shortcut. Well, we proved that the triangles were congruent by angle, side, angle. And side, angle, angle is the shortcut because if you know two angles in a triangle, you can figure out the third angle. And after we figured out the angle, we had angle, side, angle, and we already knew this worked. so again, all we did is we figured out the missing angles, and by angle, side, angle, it worked. So side, angle, angle must also work. So then the congruence conjecture, there should go. If two angles in a non-included side, so it's not between the angles of one triangle, are congruent to the corresponding two angles in non-included side of another angle, then the triangles are congruent. The last one is angle, 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 a congruence shortcut. If three angles of one triangle are congruent to three angles of another triangle, must the triangles be congruent? So at your table, you're going to construct a triangle, one that's 80 degrees, one that's 45, or with one angle that's 80 degrees, one that's 45, and one that's 55. So to do that, maybe you start with a line. Let's say you measure 80 degrees. Draw a line. From that new line, you would turn your paper, or actually just start over here, measure another angle, either 45 or 55, draw your line, and that last angle should be the other measure because they add to 180. Okay, so go ahead and do that, measure your sides, all right, and then compare. If three angles of one triangle are congruent to three angles of another triangle, do the triangles have to be congruent? Explain why or why not. And if you do this at your team, you'll notice that even though your triangle has the same angle as your teammates, the sides are different. So this is no. They can have congruent angles, but the sides can be different lengths. All right, so angle, angle, angle is not enough information for using it as a shortcut. So let's review which theorems work and which theorems do not work. So the ones that do work from yesterday were side, side, side works, side, angle, side. The ones that worked from today were angle, side, angle, and side, angle, angle. These are the four that work, and all other ones do not work for a congruent shortcut. So now the problems. For each of the following, name a triangle congruent to the given triangle and state the conjecture. If you cannot show any triangles to be congruent, write cannot be determined, or write CBD is fine, and explain why. All right, let's look at the first one. We have some parallel lines, so we know the alternate interior angles are congruent. We know they share this side. We know this angle matches up with this angle, and this angle matches up with this angle. All right, do any one of these work? Well, we can't use side, 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 but we could use side, angle, side. So we could say by side, angle, side, this works. We could also say by angle, side, angle. All right, so when you name the triangle, you have to name it in the same order. So what matches P, T does. What matches I, O does. And what matches the T here. Let's see, P, I, T, so it'll be T, O, P. So again, write it in corresponding order. Okay, the next one. PS is an angle bisector, so that means these two angles are the same, of QPR, and we know they share this side right here, and we know if this is 90, this has to be 90. All right, so this one right here, we have angle, side, angle. So just name it in the same order. PQS is congruent to PRS. Next one. There's ACN. ACN is this triangle right here. We know that both triangles, this triangle and this triangle, they share a side, this bottom side. So if I'm just gonna draw ACN separate. It's kind of hard to see here. So here's ACN. It shares this side with the other triangle. We have this angle and this angle. So it looks like we have angle, angle, and a side. Side, angle, angle. So by side, angle, angle, the two triangles are congruent. So name them in the same order. ACN is congruent to NRA. And the last one, again, we have parallel lines in a transversal. So we know the alternate angles are congruent. We have vertical angles, so those are congruent. And we know these sides are the same. So again, this is angle, angle, side. Or we could have said, all right, these angles are also the same. So we also have angle, side, angle. So they're congruent. X, V, W is congruent to X, Z, Y. All right, so to summarize, here are the 4 theorems to prove two triangles are congruent. The assignment is on your calendar, I believe, so you can get started on that.